So you do a calculation in an exam correctly, but when you get it back, you see that you were marked wrong. How's that possible? Well, it's most likely that you had the incorrect amount of significant figures in your answer. So we are going to review right now how to get the correct number of sig figs from doing calculations. And there's two scenarios. We have addition and subtraction that we're going to go over, and multiplication and division. Now, I did review already how to get the correct number of significant figures in a number in my last video. So go check that out if you haven't seen it yet, and then come right back and let's go over how to do mathematical operations and get the correct number of sig figs in your final answer. And before we jump in, guys, if these videos help you, please give a like, follow, share, subscribe, comment. You can request either help with a topic that you need or a question about this video, or just drop by and say hi. And if you'd like to go further, please check me out through my links, and you can patronize me over there. That helps me to continue making these videos for free. So let's jump in. Let's start off with multiplication and division. And the rule when you are multiplying and dividing is that you need to use the lower number of significant figures from the values that are given. Okay, so let's count how many sig figs are in each of these first, and then we'll get our answer, and then we'll get the correct number of sig figs in that answer. So from my rules that I gave last time, these both have decimal points, so we start from the first non-zero and go to the end. So this has 3 significant figures, and this one just has 2 sig figs, right? So that's 2 sig figs. All right. Now, let's get the original answer. So if we do 0.231 times 2, we get 0.462. And again, if you wrote that on the exam, you're going to get it marked wrong, or maybe just a deduction, right? So we have to represent this with the correct number of significant figures. And in multiplication and division, you use the least amount from the numbers that you were given. And so between 3 sig figs and 2 sig figs, obviously 2 is the lower amount. So our final answer has to have 2 sig figs. And now here, we're going to draw our rounding bar after the second sig fig. So remember, when we're doing it with decimal points, you start at the first non-zero. So there it is. And now we just want 2 digits. So this and the next one. So I'm going to put my rounding bar here to show where I'm going to chop this off. And then this is going to round over to 0.46. And that is now our final answer. And just remember how rounding works in case you forgot. If this was 5 or above, we'd round up. So it would be 0.47 as the final answer. And if it's 4 or below, you round down and it just gets chopped off, okay? So now let's review addition and subtraction. And so in this case, we have a very different rule. It's not about the number of significant figures that is given, it's about the number of decimal places. And so let's add this up first. And so we get 7, 9, 7, and 11, right? So we're not going to go by sig figs now. We're going to go about the least number of decimal places from the given values, right? And so this has 3 decimal places, that has 2. So our final answer is going to have 2 decimal places. So that's 1, that's 2, that's the hundredths place. I'm going to put my little rounding bar there to show where I'm cutting off. And then this is going to round up, right? 7 is going to round that 9 up to 10. And so we're going to have 11.80 as our final answer. Now, if you see what happened here, that's 3 sig figs, that's 4 sig figs. We ended up with 4. But again, this is a completely different rule than in multiplication and division. This is least decimal places, and that's least sig figs, okay? There is just one exception here, is when you are dealing with infinitely precise numbers. Like if I counted 5 apples, that 5 apples is infinitely precise. It's not 5.1 or 5.2 apples. And so if you multiply something by 5 apples, you know, an infinitely precise number like that, you don't change the number of sig figs in your answer, okay? You just maintain that. And so, you know, if I just had like another example, for instance, let's just say I had 5.000 inches and I wanted to convert that to centimeters. And so we use the conversion factor that 1 inch is equal to 2.54 centimeters. I'm getting a little sloppy down here. And then when we do the math, and by the way, I have a lesson, a video on this topic, which is unit conversions and dimensional analysis, so check that out. But for the answer here, we would get 12 2.7 centimeters. Now, if you leave it like that, you're going to get a deduction or get it marked wrong, depending on how strict your professor is. So this number here has 1, 2, 3, 4 sig figs. And although it looks like the 2.54 has 3 sig figs, it doesn't, because an inch is defined as 2.54 centimeters. So this is infinitely precise. It does not affect the number of sig figs in your final answer. So in other words, I need to have 4 sig figs in my answer because I started with 4. This doesn't affect it, and I need 4 in the end. Okay? So how do I get 4 sig figs from something that only has 3? Well, again, we have a decimal point, so we start from the first non-zero, there it is, and go to the end. So I have to have 1, 2, 3, 4. I need to add a digit here, and you just tag on a 0 at the end, and now that is 4 sig figs. I didn't change the value. I just made a more precise number, okay? So multiplication, division, least number of sig figs. Addition, subtraction, least number of decimal places. When you are dealing with infinitely precise numbers, it doesn't affect the number of sig figs that you started off with. All right, guys? So if this helped, again, please support the channel by liking, sharing, subscribing, commenting, all those great things, and check out my links to patronize me over there to allow me to keep making these videos for free. Thanks again, and I'll see you in the next one.